Okay, so we're going to use implicit differentiation to find the equation of the tangent line to this curve, okay, at the point 0, 1/2. So just to make sure that this point is on the curve, if x is 0, these terms drop out, and if that is, the left-hand side is 0, and if I plug a half in for y, this right-hand side is 0 as well, okay. All right, so to use the implicit differentiation, we basically differentiate everything from left to right. So if I differentiate this first term on the left, I get the derivative of the first function, which is the 3x to the fourth, and so that'll be a 12x cubed. 12x cubed times the second function, which is y squared, and then plus the first function, which is 3x to the fourth, times the derivative of the second function, which here's where we use a chain rule. So the chain rule would give us 2 times y, and then times y prime. Okay, that's how we're using the chain rule here. So it's derivative of y squared, which is 2y, but then times y prime. Okay, and then minus, and I guess I could use parentheses, but instead I'll think of this as the function minus 7x times y cubed. So the derivative of the minus 7x is minus 7 times the y cubed. Okay, that's derivative of the first times the second, and then plus, but really minus the first, which is 7x, times the derivative of the second, which is now the derivative of y cubed. Differentiating it gives us 3y squared, and then of course times the y prime. Okay. This must all equal derivative of the 4, which is a constant, so that derivative is 0, and then minus 8 times the derivative of y, which is a 1, and then times, of course, y prime, because we're differentiating a y term. All right, with this now, what I want to do is I want to move y primes to the left, non-y prime terms to the right. So I want to subtract 12x cubed y squared from both sides. Okay. And then I want to add a 7y cubed to both sides. Okay, and so I've moved non-y prime terms from the left to the right, but I have this y prime term on the right. I want to move it to the left, so I'm going to add 8y prime to both sides. So I do that, and then so I want to cross those off, and I'm left with, and if I simplify, I have this as a 6x to the fourth y prime, and then minus, multiplying some stuff here, 21xy squared y prime, and then plus an 8y prime. Okay, that's what's on the left. And then this equals, those things cancel, and it equals a minus 12x cubed y squared plus 7y cubed. And now we factor out y prime on the left. So y prime times 6x to the fourth y minus 21xy squared plus 8. All of this equals this minus 12x cubed y squared plus 7y cubed. I just want to check my notes and make sure I have this is correct. And now the last thing to do, well, at least for solving for y prime, is we divide by what's in parentheses. So we have dy dx, and I'll write y prime when I'm done as dy dx. So dy dx is equal to minus 12x cubed y squared plus 7y cubed, okay, divided by 6x to the fourth y minus 21xy squared plus 8. All right? So that gives us a formula for dy dx. And of course, to find the equation of the tangent line, we have to evaluate this somewhere. So the slope that we're looking for is dy dx evaluated at xy equal to our point 0, 1/2. So what I do is I plug in 0 for x and 1/2 for y. And any term that has x is 0 because x is 0. So I'm just going to write 7 times 1/2 cubed. And then divided by, well, 2 terms in the denominator go away. And actually I'm just left with an 8. So this is a 7 times a half cubed, or 7/8 divided by 8. And so hopefully you see that this is 7/64. So this is the slope of this tangent line. And the actual equation of the tangent line, I have a point that's here, I have a slope, and so that equation is y minus a half equal to 7/64 times x. X minus 0, but of course that simplifies as x. And if you prefer to write things in mx plus b form, we have y equals 7/64x plus 1/2. So this would be the equation of that tangent line.